welcome to this lecture. So in the previous lecture we have implemented our Mario, the basic skeleton for our Mario game. And in this lecture we want to implement that is the enemy part. So go to this data again, and in this component just go in this component and just create a new Python file and just create it as enemy. So we have now enemy.py. So the next thing what we want to do is obviously importing some of the modules, and that would be like something pygame first. So pygame, import pygame as pg, and from dot means we are just referencing to this data now, and just import me setup. And next will be the constant to import, and that would be from data just import me constant as c. So just make sure you put c here. So next thing what you want to do is we'll just create this enemy class in order to handle this movement, and just put here the sprite dot sprite. So first we'll just make this init, that is the constructor, and this is basically enemy is the base class for all our enemy. So that can be Goombas or Koopas, and that all our enemies should be embedded in this enemy class. So firstly we want to initialize this sprite in this initializer, and just call this init here. And now next thing what you want to do is we'll set up the enemy. So just create this setup enemy function here, and just pass this self, that is our current object, and x y, and give the direction and also the name. So what would be the name of the enemy? And after that what you're gonna pass is a set of frames, that is what the movement or what the direction or facing direction of the enemy should be. So we'll just pass this bunch of parameter here. So this function will set up the various value for the enemy. So firstly what you want to do is we'll load that gfx of that enemy. So we'll just create new variable here as an sprite sheet, and just load in this sprite sheet, that is from this setup, and that should be setup and .gfx. You should see here a gfx function, and in this gfx what you want to have is let me say that is to load smb. So you can just go here and check for that. It should be here, that is this type of enemy. You can see Goombas, and also you can see here Koopas. So let's get back to this basically enemy.py, and just put here that is smb and enemies smb enemies sheet, and make sure you just spell it right as this one, that is smb enemies sheet. And after that we don't have to just put png, because in this setup you can see, just open that setup, that, and you can see here that in the gfx basically it will just load the path from this load all gfx function, which is basically in this our tools. So you can just check for this load all gfx function, and you can see there that is we have just dynamically attached the extension of the file in this spreadsheet or in this file. So next thing what you want to do is just create these frames, and that should be empty. And the frame index, obviously frame index is important, so let me say frame index is O. So next thing let me say animate timer. So this will basically handle this the animation timer. So let me say it is animate timer should be now O, and the timer that should be here death, and just give a timer here should be O again, and the gravity now. So let's put now gravity, and just define the gravity default value here, and that should be self.gravity, and this gravity would be somewhere that is 1.5 here. So after that we'll just say the current state would be, that is the default state, will be walk state. So just call this walk from the constant. So now next thing what we want is just assigning this name here and the direction. So name is basically the name of the enemy, so I'll say that is self.image here, and this should be self.frames, and just get this as self.frameIndex. So next thing what we're gonna do is we'll just create this rect out of this image, and let me say it is in self_image.getRect function. It will just get the rectangle and just assign this rect x as the previous x, and similarly you want to just assign this rect bottom with this y now. So next thing we'll just create the new function, and that would be setting the velocity for us. So this is basically setting the velocity for our enemy. So let's make this set velocity function now. So outside here, so let me just call this, and let me make a space here, and let's call that set velocity function. So I'll say set velocity, and just the parameter will be the current object, and this basically sets velocity vector based on the direction. So we have to deal with the direction here, that is if the direction of our enemy is left here, that means c dot left, then what you're gonna do is basically you'll just decrease that velocity of x, that is x well here, and that should be -2. Just make this as -2. Otherwise, if the direction is the right, then just put this x velocity to be 2. Otherwise, and just put this velocity as in y well to be O. So we have completed our set velocity for the enemy. Now let's get that image, that is the image from this sprite. So in this image, first will be the self, that is the current object, and x and y is the position from which this image extraction should be done, and the width, so give the width, so how much the width should be extracted, and similarly height. So firstly we'll just create this image variable here, and that should be initialized as pg.surface. So surface, just give here a height and width first, so that should be width here and height. So firstly height and width, and just convert it, or you can just say bit max. So next thing what you can do here is create this rectangle, and that should be out of this image, and let me say it is image dot get rect. So just make this get rect here, and the next thing what you can do here is we'll just bleed now. That means image dot bleed. So this image should be now bleed, and that should be from the surface. So first give the surface, that is self dot sprite, it should be sprite sheet, and next would be position, let me say O and O, and next one would be just a dimension here, that is x and y, and height and width, which should be first width and then height. So we have now bleed our image. So next thing we'll just get this color key basically from this constant, and that set color key. Now in order to set that color key, we have set color key function, and this will just set our color key as in black here. So next thing we'll just transform the image now. So transformation means just scaling this image in this case. So transform and just make it bigger or enlarge this image. Basically when you go in this SMB image sheet, you can see this is only the smaller images. So in order to work here, we should just increase this enemy. So what this enemy basically will just include is this one and this cell basically. So just include that now. So for that we'll just image should be enlarged, and just give a dimension here, height and width. So in this case we'll say just rect width First would be rect width. So how this enlargement should be done is just multiply with this width by something that is size multiply here, and then it should be somewhere that is 1 to 2 here, size multiplier, and it should be rect and dot width, not rect width, rect width. And then the next thing, we'll just use the same code for the height, and I'll say that should be height and just multiply again with the constant size multiplier. So if you see here the size multiplier, we have something that is 1.5. if you go here and in this constant, you can see the size multiplier is somewhere that is 2.5 here. So this is basically in float, so in the scaling we'll just convert that is to the integer. So let me just put it here, that is an integer. So this should be typecasted converted to integer, and this one too should be converted from the float to the integer. So this is the transformation for the image. Now we'll just return that image after the transformation, that is from this, basically from this return statement. So next thing what we're gonna do is we'll just handle this state now. So that means from this handle state function. So this handle state is basically an enemy behavior. So it is handling this enemy behavior based on this state. So if our state basically is walk state, then you just have to walk. If it is falling, then just fall, or jumped on or jump, or cell slide, it can be death jump. So we'll just handle that. So firstly we'll say state is equal to c dot walk here. So in this case we'll just say self dot walking. So just call this self dot walking, and we haven't implemented this walking method. Now it's time to check for the fall here. So it would be if the self, that is the current object, or in this case enemy, and dot state is equal c dot fall. So in this case what you're gonna do is just calling this falling function, and we'll just implement this falling and walking function in a bit. So else if, so what can enemy do again? So enemy just can jumped on. So that means we'll say if self dot state here is equal to c dot jumped on, then what you're gonna do here, that means you have to just make another function in order to handle it. So we'll just say this should be handled by jumped on function. And what else this enemy can do? This enemy also can just cell slide here. So just call this cell slide, and we'll just implement that as in cell slide function. So this should be cell sliding. And the next and the last one will be when this enemy basically have this death jump. So if the state is equal c dot death jump, then make another function again in order to handle these events, and that should be death jumping function. So let's implement this, all of this function. That is, first one is walking and falling and jump down and cell sliding, and obviously death jumping. So firstly we'll go with this walking. So let me just define here walking function, and in this walking what you're gonna have is, so it should be outside here, and here it should be self as in first parameter. So we'll just put here self current object. So this is basically the default state of the moving sideways for our enemy. So this is for enemy. So this is the basically default state of moving sideways for our enemy. So we'll just check for something, that is if self current object or enemy current time. So if the current time minus self, and should be self dot animate, so it should be animate timer, is greater than some random here, it should be 125 millisecond. Then we'll just check for another condition, and that would be the frame index. So if the frame index is equal 0, that means there is no animation. So we'll just increase that frame index basically with increment by 1. Elif, so if the frame index is equal to 1 here, So if it is equal to 1, what you're going to do is we'll just roll back it to again to 0. It should be O. Now we'll just set this animate timer to be the current timer, and it should be done here. That is self dot animate timer should be now assigned as in current time. So let me say it should be current time here, and let's just get this current time in our initializer. That should be here. Let me say current time, and this current time should be initialized from this Pygame module, and in this we have time, and just call this clock function. So after that, the next thing what you're gonna do here is we'll just check now. That is basically, in this case it should be now we have implemented walking here. So next thing what you're gonna implement here is, so it is not showing this current time again. Obviously it should be self.current time. So next thing what you're gonna do here is we'll just implement this falling function. So let's call that here, that is define the falling function for our enemy, and the parameter here will be only this current object. So this is basically the code for when it falls off the ledge. So we'll define is if the velocity, that should be current object y velocity. So if it is falling, that means we have effect only this y velocity. So if it is less than 0, so this means if this velocity is less than 0 is basically if it falls off the ledge, then what you're gonna do is we'll just say that is this y velocity now should be added with our gravity. So there will be the gravity, and we just have to account this gravity now. So after that, what you're gonna do, define the another function, and here is the jumped on now. So let's define that jumped on function, and this should be jumped on, and it will take the current object and just pass here. So this is basically a placeholder for when the enemy is stamped on. So next thing what you're gonna here do here, let me say it should be death jumping now, because it should be now death jumping. Yes, it should be death jumping here, and just call this with current object, and basically this is for our death animation. So we'll say something that is with this rectangle here, and just assign this rect here. The x coordinate of the rect should be added an increment with this velocity, that is y velocity, and this should be not x, it should be y velocity. And similarly, if it is x velocity of this rectangle, then we should account this x velocity here. And similarly in this y, after this y we have just added in this rect, this y velocity should be added to this gravity. So this is basically a death jumping, and we'll just check if self.rect.y, this is the pixels, and if it is greater than 600, then self.kill here. So the current object will be killed, because this kill was basically from our setup module. So we'll just kill that object now, and we'll just define another function here, and that would be define start, let me say start death jump now. Should be death jump, and now what you're going to have is self and direction now. So this basically start death to jump function is to handle the transitions and that of enemy into the death jump state. So if it is in death jump state, we'll just handle here transition of the enemy. So firstly we'll just say that is self.y velocity now should be decreased to -8. So basically this velocity will be decrement, and if the direction, so if it is moving, that is our enemy is moving in the right direction, that is from this c dot right here, should be right. So if it is in the right direction, then what you're gonna do is we'll just set this velocity now to be somewhere that is, let me say 2, and else just reverse that, that is from this x velocity should be equal to -2 now. So the important code comes here, that is firstly we'll just set the gravity to be 0.5 for the enemy and the frame index. So this is important part. So frame index should be 3, and we'll now just extract that image from our frames, and that should be just get that image from the frames. So that should be here frames, and just get this current index, that would be frame index, and just get that current image. And we'll say now after this death jump, now state should be c dot death jump. So c is referencing to death jump here. So we have implemented start death jump. Now it's time to implement our animation. So this should be just defining animation here. So let me just define animation, and I'll say self this image, that is the image here should be now self dot frames, and just get that image from the frame index. And this animation is basic animation switching between the two frames. So next thing what you're gonna do is we'll just call this update function. So update will basically update our game object, that is taking the game info and obviously this packing of the arguments. So if you wonder what this args is basically, so you can always reference to my basic lecture to see the packing and unpacking of these arguments. So that would be really helpful for you here. So this basically updates the enemy behavior. That means what you're gonna do here is we'll just set this current time to this game info, just get that game info, and should be now current time, obviously this current time. And now what you're gonna do next is we'll just handle now events, that is from this handle state function, just calling handle state, and we have defined this handle state at this beginning here. And after that what you're gonna do next is we'll just call this the animation again. This is basically setting us an image of this current frame index, so just call that animation. So next thing what we're gonna create is the next class. So this class will be basically referring to the enemy. So this is enemy class, but now will be just specific enemy, so it is just restricted to the specific enemy. That means if we need, that is goombas here. If you wonder what this goomba is, let me say here. So enemy here basically it is inheriting. So if you see here that in this parenthesis we have put this enemy, that means we have inheritance here. So in this goomba can use all the functions, all the attribute of this enemy class. So this goomba is basically when you go to this SMB enemy sheet, this is basically our goomba. So let's create this goomba now. So first what you're gonna do is obviously our initializer part. In order to just init, just call this initializer, and let me just put here, and this initializer will take our self, and the next thing will be the y value and a x value, and obviously the direction here, the direction it would be pointing basically. And obviously if you say here the name, so name would be here specific, that is goomba. So x and y, we have y and x, and next would be the direction, that is either left or right, and just name. So give the name as a default value here, a goomba, and the direction has this default value, that is c dot left. Basically it is moving to left direction. Our player will be moving in right and the enemy will be moving to left, and this x here should be O now, and y distance should be c dot ground height. It should be ground height, it should be moving in this ground height basically. So next thing what you're gonna do here is we'll just implement this init method from just calling this enemy dot init method. So after this we'll just put this self here, that is the current enemy, that is in this case we have a goomba. So next thing what you're gonna call is we'll just call this setup enemy here, and this setup enemy is basically our own function, and I'll say that is setup enemy here. And this setup enemy, if you wonder what this setup enemy is about, you can just go here and you can see this setup enemy. So this is basically the method of this enemy, and we have inheritance here. That means we can use that setup enemy in this Goomba class. So now what you're gonna do here is basically you'll just put this x, y and direction, and that should be direction and enemy here. So direction means it should be name, not enemy. So just pass this name and self dot setup frames. It should be setup frame here. Frames. Let me set up frames. So next thing what you're gonna do is we'll just create this setup frame method. So let me say setup frames and just give this self here, that is the current object, and let's define this. So this setup frame basically puts our image frame in the list to be animated. So it will just create a frame and where we'll have the bunch of images to be animated. So let's create that. So first I have already said you, so this should be frames. So let me create a frame, and in these frames it should be frames, and in that frame we have to append now, that is the image. So let's get that image first. So that should be Goomba here. So in order to get image, we have get image function from our enemy class, and just give a position here. That should be on4, and 16 would be width and 16 would be height now. So after that we have extracted this Goomba. Now let's again append another one, that is from this position. Let me just give here a position, and that should also be extracted from this get image function, and let's give the position. 30 and 4 is the position, 16 would be width and 16 would be height. So next thing would be also this is, let me just copy it now and just copy it here and paste it now, and instead of this position let me just erase all of it, and let me just pass here 61, and O will be the position, 16 will be the width, and 16 will be the height. So next thing what you're gonna do is, we have now, this is for the right basically. Now we have to just flip this. Basically we'll just make use of a transform function in order to work with the flip. So we also should append that now in these frames. And how this basically transformation works is, you just use this PG, that is Pygame module, and transformation and dot flip here. So if you wonder what this flip is really about, so if you have ever worked basically with this, when you flip the pages of your book, so same is in this case. Basically we'll just make an image to flip in this case. So I'll say that is the frame, that should be frames, and just give a wipe 1 here, and now the next will be x bool and y bool. So x bool would be, let me say it should be false, and y bool would be true. Y bool would be true because there is a flip in the y position. So this next function will be important. So this function is implemented when the Mario basically hits that Goomba. So when this Mario basically jumped on in this Goomba, so what should happen? Just let's implement that in this jumped on function. So when this Mario just hit at the top of this Goomba, then Mario just squeezes him. That means this Goomba should now be killed and its object should be removed from the gameplay. So let me just define that frame index for it. So that should be 2, and I'll say if self dot current, and it should be current time here, if the current time and minus self dot death timer, and if this death timer is now greater than 500, and this attribute are basically from this enemy class. So if it is greater than 500, you just want to kill that Goomba. So let's implement this skill function, and this skill function is basically, if you see here, this skill is from this setup here. So we have implemented a bunch of function for the enemy, and that will be the wrap for this video. In the next lecture we'll implement something that is a coin for our game. So see you there.